Hey, welcome back to The Explainer. So, today we're going to dig into this really cool software testing technique. It's called state transition testing. And it all boils down to a super simple but really important question that applies to pretty much every device you use every day. No, really, think about it. When you press a button on your TV remote, your phone, anything, what is actually going on under the hood? I mean, sure, you expect something to happen, right? But what you don't see is this hidden map of rules that's running the whole show, dictating every single action. And to really get it, let's look at something we all know. To get to the bottom of this, we're going to use a super simple classic example, a digital watch. It's honestly the perfect way to see this whole complex world of states and transitions that's basically hiding in plain sight. So let's peel back the curtain a little bit and explore the secret life of this watch. We're going to map out exactly what happens with every single press of a button. Okay, so everything has to start somewhere. Let's say your watch is just in its normal default state. It's showing you the time. You reach down, you press the change mode button, and boom, the display instantly switches over to show the date. Simple action, clear change. But what if you'd pressed a different button? Okay, but what if, from that exact same time display, you hit a different button like reset? Does it show the date? Nope. It jumps into a totally different mode, alter time, the one where you can actually change the hours and minutes. See that? Same starting point, different input, completely different outcome. What we've just been doing here, describing these button presses, those are the absolute core building blocks of this entire concept. So now, let's give them their proper official names and really break down what's going on. This is it. This is the key. A state transition is that exact moment of change. Your watch, moving from displaying the time to displaying the date, that's a perfect state transition. It was triggered by the event, which was, of course, you pressing the button. And this right here, this brings us to something that trips people up all the time. A state is the condition the system is in right now, like being in time mode. The event, or the input, is the trigger. It's the action, like the reset button getting pressed. They are not the same thing, and keeping that straight is absolutely crucial to getting this right. You know, the best part about all this? We don't have to just keep all this logic floating around in our heads. We can actually draw a map of the system's behavior. We can make it visual, so it's easy for a whole team to look at and understand. So for our little digital watch, we can pretty easily identify four distinct states. It can be showing the time or the date, or it could be in a mode to alter the time or alter the date. Just think of these as the main destinations on our map. And here's how we start to actually draw that map. It's simple. We just represent each state as a little node, so one for time and one for date. Then we just draw an arrow between them and label it with the event that caused the change. In this case, pressing the change mode button. And from there, we just keep adding the other paths. Pressing reset while you're in the time state, that creates a path to alter time. Pressing reset from the date state, that's a path to alter date. And all of a sudden, the entire logic of the watch becomes this super clear visual diagram. Now, if diagrams aren't really your thing, no worries. You can represent the exact same logic in what's called a state transition table. It just clearly lays it all out. If you're in this current state and this input happens, the system is going to move to this next state. It's really just a different way of looking at the very same map. So, how do we take this whole concept and turn it into a formal, repeatable testing strategy? Well, thankfully, there's a really clear step-by-step process that testers follow to make sure it all works like it's supposed to. It breaks down just like this. First, you identify all the states, just like we did. Second, you figure out all the inputs that can cause a change. Third, you make that map, your diagram, or your table. Now, the fourth step is the big one. You design tests to walk along every single one of those paths. And finally, you run the tests and prove the system actually does what your map says it will. Okay, this all sounds pretty logical, but why go to all this trouble? What's the real-world value of using state transition testing? Why does it matter? Well, the advantages are huge. You get this crystal clear visual of how the system is supposed to work, which is fantastic for team communication. But, it's not a silver bullet. In a really complex system, I'm talking about a whole banking application or something, trying to map out every single state can get incredibly difficult fast. And if your map is incomplete, you're at risk of completely missing some pretty critical bugs. Knowing the challenges is half the battle, right? So, to wrap this all up, let's look at some of the common mistakes people make with this technique, just so you can avoid them. The biggest takeaway here is just to be thorough. Don't just identify the obvious states. Really dig deep for the weird edge cases. And don't just test the valid paths. You have to test what happens when an invalid button is pressed. And always, always remember, a state is a condition, not the action that got you there. I absolutely love this phrase from the source material because it just perfectly nails the core benefit here. These diagrams are all about capturing the dynamic behavior, the life and the movement of a system. It's not a static picture, it is a blueprint for action. So, the next time you use an ATM, a vending machine, or even just navigate a website's login page, think about this. You're not just clicking buttons, you are walking a path on a hidden map. So, what other state diagrams are you interacting with every single day? Thanks for tuning in to The Explainer.